Hello, this is the second video for section 3.3. Example 2. Find the maximum and minimum values of c equals 2x plus 3y subject to the constraints below. Before we get started, I do want to label my axes real quick. We're going to want to go up to 60 on both the x and y, which means it would be 30, 15, 45, 15, 30, 45. And that does mean each tick mark is 3, not 1. So just keep that in mind. Each tick mark is 3, not 1. So now I'm going to answer this question. We need to find the feasible region first, which is equivalent to just graphing the constraint. So I'm going to find my boundary lines first. And instead of solving for y, I'm going to use the cover-up method to find my x and y intercepts. So if I cover up y, I get x equals 48. So 48, 0. And if I cover up x, I have to divide by 2, but we get y is 24. So 0, 24. So 24 would be there, and 48 would be there. So there's that boundary line. X plus y equals 30. If I cover up the y, I get x is 30. If I cover up the x, I get y is 30. So we get 30 to 30. And then the last one, I want to do in blue, is 2x plus y equals 50. If I cover up the y, I need to divide by 2, so x is 25. If I cover up the x, I just get y is 50. About right there. And then 25 is about right there. Completely missed it. And now I need to find the feasible region. Notice there's 1, 2, 3, 4, 5, 6, 7 regions I possibly would have to check. I also want to mention I didn't forget x and y are greater than or equal to 0. That just means we're in the first quadrant. So I'll pick the point 1, 1 first. So is 1 plus 2 times 1 less than or equal to 48? Check. Is 1 plus 1 less than or equal to 30? Check. Is 2 times 1 plus y less than or equal to 50? Check. Is 1 greater than or equal to 0? Check. Is 1 greater than or equal to 0? Check. So our shaded region is this pentagon shape. So now that I've graphed my feasible region, the next step to solving the problem is finding the vertices. So the first vertice is 0, 0. Oh, give me 1 second. There we go, it's back up. So the first point is 0, 0. The next point is the y-intercept of the purple line, so that's 0, 24. Now this point is the intersection of the purple and green line. So I actually have to go through that and solve it. So let me go through and do that. If I label these A, B, C, I'm just going to do elimination. So A and B are the purple and green. So I'm just going to go A minus B. X minus X, 2y minus y. So we get y. And then 48 minus 30 is 18. Now, if I plug 18 back into B, we get x plus 18 is equal to 30, so x is equal to 12. So that means our point is 12, 18. Next, I need to find the intersection of the blue and green line. Again, I'm just going to use elimination there. So I want the blue and green line. So blue is C, green is that. So I'm going to go C minus B this time. So 2x minus x is x, y minus y is nothing, and 50 minus 30 is 20, so I get x equals 20. Plug that back into b, we get 20 plus y is equal to 30, y equals 10. So then that point is, get back to the right color, there we go, is 20, 10. And then the fifth point down here, which is the x-intercept of the blue line, which I found right there, is 25, 0. So those are our 4 vertices. I did go through the elimination problem process a little quick. You can pause the video down, slow it down to figure it out, or do it off on the side, or even email me to ask for further clarification. So now that I found my vertices, I have to plug them back in to the objective function. So actually, let me move it over so I have a little bit more room. So I'm going to go 2 times 0 plus 3 times 0, which is 0. 2 times 0 plus 3 times 24, which is, what is that, 72. 2 times 12 plus 3 times 18. Let me get my calculator out for that one. 78. 2 times 20 plus 3 times 10, which is 70. And then 2 times 25 plus 3 times 0, which is 50. So now we need a maximum and a minimum. So our maximum value is 78 and our minimum value is 0. So C has a max at, a max of 78 at 1218 and a min of 0 at 0, 0. And that's how we do that problem.